Hey, welcome back. Welcome back to another Just 5 Mins. So what have we got this time? Is RAG really expensive? And if you don't know what RAG is, it's Retrieval Augmented Generation. Okay. So the idea is, well, first of all, what is RAG? What does it do? Let's have a little chat about that first very quickly. So, one of the descriptions is RAG enhances LLMs by retrieving relevant external information, e.g. from documents, databases, files, Excel sheets, whatever, at query time. Okay, then feeding that into the prompt that you're asking for. This allows the LLM to answer with up-to-date or domain-specific knowledge without retraining. So that's the key bit, is you don't have to necessarily retrain an AI model, because it can be very expensive to do that. It can also not be too expensive, but there's lots of factors at play there, whether you're using local LLMs or SLMs, things like that. But generally speaking, it can be quite costly to retrain an AI model. But there are options, things like RunPod and a few others, that will allow you to use really, really powerful GPU-backed processors to train an AI model. And if you're only doing that once or a few times a year, you're only paying for, it's literally on demand. It's like AI processing as a SaaS. But yeah, RunPod's a good one. There's a few others. But either way, retraining, there's quite a bit of work there to do that, and again, potentially cost. But RAG also then has the potential of costing, because if it has to keep looking at documents and so this by now, all AIs are charged by tokens, etc. So the more stuff that the LLM has to do, the more tokens it's using, and of course the more the cost. I mean, those billions have to be sort of recovered somewhere, don't they? That's still mind-blowing, that whole side of things, isn't it? But anyway, the idea is that RAG doesn't have to be expensive. It can be if you're repeatedly reprocessing large documents for every query. So if you've just got a store, an index of documents, databases, Excel sheets, whatever it might be, and you're reprocessing that for every time a prompt is being sent, then yeah. But the idea is it becomes expensive if you've got very changeable data. So your database could be classed as a very changeable set of data, obviously. Your Excel sheets could be, your PDFs could be, but if they're relatively static sets of data, even in your database, maybe there's a summary of whatever, sales figures or something, and PDFs that don't change that much, and things like that. So what you can then utilize is like vector storage. Okay, so there's a load of these vector databases out there. I keep forgetting the one that I really liked. I thought it was ChromaDB, but I think it's a different one. But there's Pinecone, Weaviate, all sorts of things. But of course, if you are Microsoft-centric and want to take advantage of that avenue, as of I don't know, when was, about a month or two ago of the time of this recording, SQL 2025 has now got vector storage, essentially. So you can now utilize that. And why is that important, you ask? Well, it's essentially all of this RAG stuff. What you can do, if it's slow or rarely changing data, you can actually pre-process this and create vector embeddings. Okay, so these embeddings are I did a whole episode on about vector embeddings. You could probably use AI to go and get a summary anyway. But vector embeddings is where your text or whatever isn't just turned into AI understandable code. It's context. So you've got like grouped sort of terminology and words and all of that sort of thing, and it groups them into higher dimensional sort of vectors, which are ultimately just numbers, but those numbers actually mean something, and it's the vector embedding model that has been trained to recognize words that are like a cat and a dog are both animals, so it doesn't just magically do it. It's your vector embeddings are using another model to to generate those vectors in the first place. But once those vectors have been generated, those vector embeddings, you can actually store these efficiently in a vector database like SQL 2025 now, or others that are out there. I still can't remember my favorite one at the moment, but anyway, it'll come back. So the idea is, once you've got that vector store, your RAG process doesn't have to be that expensive anymore, because it's not trying to go and do those vector embeddings along with your prompt every time. Yes, you're still paying a cost of some sort, certainly in the way that you're going to get that vector embedding data back out of the vector store, but you're not necessarily going to be reprocessing all of those documents from an LLM perspective. So there's a lot of layers here that you can trip up on, and I'm sure I have as well. But the point being is, if you can pre-process these slow-moving data sets, documents, Excel sheets, whatever it might be, but if they are actually live and you need them as up-to-date as possible, then yeah, okay, RAG can get expensive, but generally it doesn't have to be so. And of course, more and more people are looking seriously at local LLMs or SLMs, because in a lot of ways, if you've got, I don't know, a knowledge base, say for instance, and you've got PDFs in, you've got some data that, okay, it might get added to maybe once a week, once a month or something like that, then, it's potentially a good idea to go and pre-process that data once a month, say, create the vector embeddings store, and and again, you don't need a massive large language model necessarily. You can get away with things like Phi from Microsoft, or use Llama from Meta, or all of these, DeepSeek or whatever it might be, that can run locally on your own infrastructure. So that cuts down the cost. Okay, you've still got to host that, you've still got to do all the usual compute processing and stuff like that. But the point being is, there are lots of interesting ways that you can take advantage of RAG. So you're not fine-tuning a model like even every couple of months or something. It's still quite a lot of work and a lot of cost to retrain and do fine-tuning on an AI model. But RAG, you can slot in, like I say, extra documents. Again, if it was every minute, every day even, yeah, probably not. But if it's sort of like a slower moving process that you've got, then yeah, I think RAG is a perfectly acceptable way of doing it, and it's not really that expensive. You can work out the details, I'm sure, but and there's lots of other examples. But the point being is, the way that the vector embeddings work anyway is, like I say, the vector storage is storing those vector embeddings anyway, already pre-vectorized. There's also ANN indexing, which is the approximate nearest neighbor, which is one of the main algorithms that is used for finding similar words and things like that, and that can be indexed, which is really cool. And then you've got quantization, and the best way I've got of explaining this is the fact that, when you used to have, you don't worry about it these days because everybody's got, super fast broadband and whatnot. But your, excuse me, sorry about that. But where you used to have images that were a little bit pixelated because you said, okay, it's medium quality, not high quality. So you had slightly pixelated images, but you could still easily and comfortably work out, yeah, that's a cat, that's a dog, that's a scene by the beach or whatever it might be. Well, the way that you can take advantage in the AI world is something called quantization. Again, a whole story in itself. I did a little bit of an intro to it a while ago, but it essentially compresses those vector embeddings. So instead of things like, if you want to get technical, if you've got a float 16 or an int 16, to get that accuracy, you can imagine if you cut that down to float 8 or an int 8, like 8-bit instead of 16-bit, or even 4 if you really want to be quite wild, that's quantization. But the good thing is it reduces the memory footprint and speed of retrieval, but it's with minimal accuracy loss. And it's a bit like I said, the easiest way was looking at a slightly pixelated image. You can still tell what that image is very clearly, but you've gained a lot of compression there. Okay, so there's other methods as well that go on in that. And talking of going on, I think I've gone on way too much. It's never going to be 5 minutes, this podcast, is it? But hey, it's a goal, something to aim for. Anyway, that's what I've got for this time. Now, what I've also got is how you can take advantage of semantic kernel, which is the Microsoft AI framework that's underneath a lot of these other, like autogens and stuff like that, or at least comparatively the same as those sorts of things. But it's quite a foundational SDK in the Microsoft world. Well, I've got a little demo video on good old YouTube, I guess, where it's showing the semantic kernel RAG pipeline with MS SQL 2025 with the new vector data store. So I'm going to go through the setup of that using with RAG, by the way. This is what we're talking about, the pre-processing of these RAG sort of assets, documents, data sets, Excel sheets, whatever, and actually being able to create those vector embeddings and then store them in SQL 2025 because it's now got vector database support. So that's coming soon, probably in the next week or two, as of the time of this recording. So that's what I've got anyway. So thanks for listening if you made it this far. Sorry about the coughing halfway through the podcast. And I haven't had enough coffee this morning, that is for sure. Anyway, hopefully you have a good day, good week, wherever you are. And we will catch you on the next one.